Welcome to today's webinar, Building a CICD Pipeline for Container Development to Amazon ECS. Our presenter today is John Pignata, Startup Solutions Architect. John, welcome. The floor is now yours.
Hi, everyone. I apologize for starting a couple minutes late. I had some technical difficulties. So thank you for joining us today. My name is John Pignata. I'm a Startup Solutions Architect, as mentioned. I am excited to dig in today to Amazon EC2 container service and building continuous integration and continuous delivery pipelines using our code services. Okay, sorry about that. So just to give you an overview of what to expect from this session, we're going to spend a few minutes just kind of reviewing the terms continuous integration, continuous delivery, and continuous deployment. We're going to talk about some of the activities that are involved in these different phases and contrast the terms just so that we have a shared foundation to continue the conversation. We're then going to talk about using Docker images, Amazon EC2 Container Service, and Amazon EC2 Container Registry for powering a CICD workflow. We're going to dig into different kinds of deployment strategies with Amazon ECS. So we're going to look at some of the ways you can, some of the strategies you could employ in deploying containers. That includes things like blue-green deployment, a Canary deployment, and a rolling deployment. We're going to talk about a newer service, AWS CodeBuild, and how to use that to build Docker container images in a really cost-effective way. We're going to look at a fully working end-to-end AWS CodePipeline deployment pipeline, taking our code from our source code repository in AWS CodeCommit all the way to production in our EC2 container service cluster. And I'm going to show a little demo very quickly of how you might set this up just using the AWS Management Console. Okay. So let's start just reviewing the terms continuous integration, delivery, and deployment. And to do so, let's back up, sometime, let's go back 20 years ago. When I'm talking to customers that are starting new businesses and building on top of AWS, the thing we hear about is 20 years ago, these customers just wouldn't be able to do what they're doing. The first step that they would need to take in deploying software is they would have to, write some large purchase order to a hardware vendor of some kind, wait for hardware to come, rack and stack that hardware, buy the most expensive real estate you could imagine in a data center, and wire it up with power and ping. And then at that point, they could then deploy their software. With AWS and the advent of the cloud, that's no longer that undifferentiated heavy lifting is no longer the concern of the startup. The startups can concentrate on the code they're writing and the applications they're building and the customers they're serving and leave the infrastructure heavy lifting to Amazon Web Services. And the important bit here is that this leads to increased agility. So customers, instead of having all of those tasks as a precursor to deploying their application, can instead deploy quickly. And this encourages experimentation and innovation. So customers can deploy a new application to AWS very quickly, within minutes. And if that experiment fails, or if the application was not successful, you could deprovision those resources without any kind of concern. So the introduction of the cloud and rapid provisioning of resources really unlocks a lot of agility. But the amount of time spent provisioning resources and building infrastructure is only one potential part of waste here, right? There are other potential points of waste in development processes. And what we want to talk about today is how can we limit the amount of time it takes between a change being made to a piece of software to that software being deployed to production. So to frame this conversation, I'd like to use this question. So how can we quickly and reliably deliver good ideas to our customers? So quickly, obviously, we want to be as agile as possible to be able to move our product forward to our customers as quickly as we can. However, we can't sacrifice reliability in the goal of agility. We need to ensure that we're reliably deploying to production, especially if we're deploying many times a day as opposed to once every, on a bi-weekly cadence. And lastly, a good idea. Well, what is a good idea? And frankly, we don't know until we get it out to production. So shortening the cycle is really important. Frankly, I just want to also, just to build a shared foundation here, I want to go through some learnings or tenets, some assumptions we're making about the software development lifecycle and things we've learned throughout the years as an industry, frankly. So the first, I just want to briefly go through this list. Frequency reduces difficulty. So this is sort of counterintuitive. Said another way, this could be said as, if it hurts, do it more often. So if you are just starting a running program and you're going from sitting on your couch to doing a 5K, you may find that first mile you run to be fairly miserable. If you wait a day and get in your rest and run that mile again sometime later in the week, you'll find it's easier to do. And likewise with deploying to production, with integrating your software with the work of other developers, what we found as an industry is that doing this more often and doing it continuously reduces the difficulty of that exercise. Next, the latency between check-in and production is a source of waste. So for every change we have sitting in a source code repository, that is a change that is not delivering value to our customers. So the amount of, as much as we could shorten that cycle from check-in to actual production service, the better for our customers, the better for our product. Next, consistency improves confidence. So when you're deploying to production, perhaps when you start off on day one, your deployment procedure is, well, we take this file and we SCP it or use SSH to send it to production, and that's our deployment procedure. Over time, that tends to grow, right? Processes tend to grow. And you may find that your deployment process is now 30 steps, and perhaps those steps are in a wiki, and maybe that wiki is not necessarily the most up-to-date information. So having consistency in your process, having some sort of scripted deployment procedure or some kind of automation will help you improve confidence and will help you reduce that latency between check-in to production. Next, as an industry, automation over toil. So toil, anything that you're doing manually, any work that a developer is doing that is not necessarily building features or building product value is toil. And we want to use automation to reduce that amount of toil to the least amount of time possible. We want to spend as much time as we can on things that matter to our customers and not drudgery tasks that can be automated in some way. Empowered developers make happier teams. Developers that can ship, developers that can quickly find a bug and fix that bug and get it out to production tend to be happier than teams that are mired in processes that take days or weeks to get changes out to production. And likewise, smaller batch sizes are far easier to debug. So if you have a bi-weekly deployment cycle and something changes in your application and that causes perhaps a performance problem or maybe has negative impact to your business metrics, it's very hard to determine what change in that 2-week cycle might be the source of the problem. If you're deploying small batch sizes, maybe on a continuous basis, it becomes very easy to debug. It's simply, we were running fine, this change happened, which includes one commit, we're going to roll back that commit and investigate. And then finally, faster delivery improves software development practices. So what we found as an industry is that the faster we try to get software out to production, the more software hygiene, or the more hygiene we introduce into our software teams to accommodate that sort of agility and that sort of speed. Okay, so that's just some shared, some tenets to kind of go through as a basis for our conversation here. Next, I want to walk through sort of the different elements of a deployment pipeline and the different phases and some of the activities within those phases. So in our source phase, there are activities like this is where the actual work is being done and the code is being written. Here we have a team of developers working together. We're using version control systems. Perhaps we're using some kind of branching within that version control. Maybe we have a code review process internally where code is checked through maybe a GitHub pull request, or maybe you're even doing pair programming or something of that nature. So that's the first phase where the actual code is written and stored in a source control system. And that leads to a build phase. So once our code is written and in source control and in some sort of master or mainline branch, now we're at the point where we can build that code. And what happens in the build phase? There are steps like compilation. Perhaps you're using some sort of compiled language where you have to take the source code and compile it. In this phase, maybe we're writing unit tests to design and test our objects or our components. Maybe we're using static analysis. So there are lots of teams that we work with that employ static analysis to test code without executing it for things like conformance with a shared team style guide, check for common security issues, that kind of thing. And then finally, in the build phase, we're packaging our code for deployment. So here, maybe we are building some sort of package file, like a jar file, or perhaps we're building some sort of like a Docker container, as we're going to walk through in this talk. So a deployment and artifact that's ready to go from our build system all the way through to production. Next, we have a test phase, and here we do more thorough testing at a higher level. So here we may be running integration tests, so not just testing the design of our components, but actually testing those components against the rest of our system or third-party systems. Maybe we're doing some kind of load test to ensure the performance of our new component. Maybe we're doing security testing, some sort of penetration testing or otherwise. And maybe we're running acceptance tests. Maybe we have some browser automation for our web product that runs through our website as a user would. And then finally, we have our production phase. And in our production phase, the first step is deployment, right? But that's not the end of the production phase. In production, we have other activities such as monitoring what we've deployed. That's both operational monitoring and, on the business metrics side, and measuring and validating. The change we've made, obviously we had a goal behind that change. Is that change meeting its goal? Does this validate our hypothesis? And for each of these four stages, let's talk a little bit about where continuous integration, continuous delivery, and continuous deployment fall. So continuous integration covers the first two stages here of source and build. So instead of having your team of 5 developers all working on individual paths or features in your product and coming together after some time, let's call it several weeks, to integrate those changes together, we're instead continuously integrating those changes into a central branch. So here we're saying feature A, feature B, feature C. Each day, code changes are being made, and those changes are being reviewed and merged into a central branch. In the old days, we would wait weeks and weeks, and then there'd be a big bang kind of integration. It's very painful, and what we found as an industry is that the more often we integrate, the less painful it is, the less difficult it becomes. So that's continuous integration. Continuous delivery goes beyond the source and build stage by taking the artifact that we've built in the build stage and putting it under higher level tests. And so ultimately, we have an artifact now that's tested, it's built and tested, and we have a gate here. So we have an artifact that can go to production. In continuous delivery, we're not shipping that artifact all the way to production automatically, but we do provide a gate of some kind, perhaps a way for a developer or someone on the team to click a button and deploy that to production. So that's continuous delivery. And continuous deployment is the obvious extension of that, where we remove the gate and we take that out and we deploy it right to production. So automatically, every commit that hits our integrated master or mainline branch goes right to production. So that's where the 3 different terms fall with the phases of a deployment pipeline. And most importantly, through all of these phases, we're getting feedback from our tools. When we're continuously integrating, we're getting feedback. We perhaps have a build that happens on every commit. And if that build breaks, if our tests fail, if it doesn't compile, if it can't be packaged appropriately, we'll get some sort of red light somewhere to tell us that it needs attention. Likewise, with continuous delivery and deployment, if we have a continuous deployment pipeline, that feedback becomes very important. How is the new revision of the software operating in production? What is the effect on our business metrics, etc.? Okay, so we're going so that's the foundation of what we're going to talk about. Now let's talk about some of the specifics. So I want to go through each of these stages specifically for containerized workloads using Docker and using the EC2 container service. So let's start with Docker images. And just a brief overview. So a Docker image is a packaged application code and runtime dependency in an immutable image. This image is built from a Docker file, which is a set of directives that build up that image in a reproducible fashion. And when we have our Docker container image, this is now portable. So we can run it locally in our development environment, we could run it in a user acceptance testing environment, and ultimately we could run it in production portably. A Docker image is composed of a set of layers, and these layers build upon each other. So here we have a hypothetical Docker image called microservice, tagged with the latest tag. And we have 4 layers that constitute this Docker image. Each image represents work done within the Docker file directives. So the Docker file directives define what is in that layer. So here we have a small little Docker file here that is deriving our Docker container image from Amazon Linux, a specific tag of Amazon Linux, March 2017. We're installing dependency, so here we're installing Nginx. We're copying a file into our Docker container image, and we're defining how to start that Docker container image. So when we run our Docker image, we want our application to start. So this is now a Docker container image that we can ship to production and run portably. And we can have many versions of our Docker container image. Here we have semantically versioned 4 different versions from 1.0.0 to 1.2.0. And we can store these Docker container images in a container registry. So on the AWS platform, we have the EC2 container registry, which is a Docker registry that you can use to store images. There are other container registries as well that our customers use. And this allows you to reference that image and access it from different locations and different environments. So we can now have a staging environment, perhaps, that is pointing to or using our microservice 1.2 image, while perhaps in production we have 1.1.1. And as I said, now we have this image, and our Docker container image can move between the different layers of our application. So just some best practices on the build stage, and just to talk about some of the things we've seen customers do that have worked well for them. So one, you want your Docker container image to be as reproducible as possible, meaning if you build your Docker container image today and you build it in a month from now, you want the same result at the end of that build process. And one way to ensure that is by pinning external dependencies to specific versions, meaning instead of pinning to a latest tag of in your from directive, or pinning to some sort of when you install a dependency, not specifying a version. We find that especially when you're doing continuous deployment, you want to ensure that these build processes are automated and happening in the background, that you have some predictability in what these build processes produce. Likewise, we've also seen customers have a lot of success by ensuring that they're packaging only the runtime requirements for production. So with Docker, especially with certain kinds of platforms, you can end up with very large containers that include your entire build environment. What we recommend is, and what we've seen customers have success with, is ensuring that the image that's produced at the end of that build stage has the minimum amount of requirements needed to run in production. Meaning, if you're using something like the Go language, instead of deploying a container that has all of the Go build tools, you just deploy a container that has the specific application code itself, what the executable, and what's required to run that executable. Likewise, for speed, you want to ensure that your deployment process is as fast as possible, especially when you have a bug fix going to production. As it makes its way through the pipeline, you want to ensure that each step runs as quickly as it can. So minimizing changes in each layer really helps maximize cacheability. So if you have 4 Docker directives in your Docker file, ensuring that the changes between the layers are minimized will help ensure that you can cache, let's say, the first 3 layers. So if a change only happens on the 4th layer, you could then, let's say that's the layer where you copy your file in, and that's what's changing because it's your application. You could save the build time for the first 3 steps. And we've seen customers do things like extract a common base image across different microservices or different applications, or implement caching on their Jenkins build server to cache those layers and ensure they're available for later processes. But whatever tools you're using, and we'll talk about some specific tools later, ensuring that you're minimizing changes in each layer and that the build process runs as fast as possible is generally a best practice. And then finally, in that vein, maintaining a Docker file, a Docker include file, or excuse me, a Docker ignore file to exclude unneeded files will help reduce the size of the image and improve speed. So that's the build stage. Let's talk a little bit about sort of how this artifact gets built now. Where does the rubber actually meet the road? So conceptually, it's very simple. There's some application code or an application, the runtime environment for that application defined as a Docker file. And then there's some sort of process that takes that Docker file and actualizes it into a Docker container image and creates that Docker container image. And there are several different, there are many different ways to automate the building of Docker images. Many customers use Jenkins, which is an open source platform for automation and software delivery. We have AWS CodeBuild, which we're going to dive into a little bit more deeply. That is a managed build service that allows you to build all kinds of different projects from Java and Ruby and all the way to Docker, and allows you to extend it with custom build environments. And others will write their own custom scripts and run scripts on EC2 instances. One thing I wanted to mention quickly is that we're going to talk a little bit about best practices of maintaining a build environment. There are many ways to do that. A couple that come to mind is just keep in mind when you're building infrastructure like this to manage your build process, ensure that you're paying as least as you can, right? Pay as little as you can. So things like the EC2 spot instances where you can basically bid on unused compute capacity for savings of up to 90%. Those are great for build processes. And Jenkins, we have a plugin to Jenkins which automatically manages clusters of spot instances. And you can use that to really kind of shave off a lot of cost for your build system. Likewise, so AWS CodeBuild is a service to build and test code with a pay-as-you-go model. So CodeBuild, instead of running your own instances and managing your own deployment, your own applications to run your builds and deploy your code, CodeBuild gives you an environment where you can do that with per-minute pricing. So instead of paying for an hour of an EC2 instance, you can just pay for the time that your build is actually running. And the really cool thing about CodeBuild is that it continuously scales. So if you've ever been on a large team that has, let's say, a couple dozen engineers on the same product, and you only have, 4 or 5 different build slots because you only have 4 or 5 different executors that do the work, you find that gums up the works, right? It slows down everybody. Everyone has to wait for their build to pass before doing continuing their integration or taking that code and doing the next step. With CodeBuild, you can just scale out in parallel. So as many builds as you have working in parallel, CodeBuild can scale out and accommodate it. And likewise, you never pay for idle time here. It's per minute billing, and it's fully extensible to other platforms through custom build environments. Meaning, if you use PHP isn't supported out of the box with CodeBuild. You can create a custom build environment with PHP unit and PHP runtime. Likewise, if you're using something a little off the wall like Elixir or some other language, you can easily CodeBuild can be extended to accommodate that. And CodeBuild uses basically a YAML file, so a little YAML configuration file to describe the different activities it needs to undertake to build your code. And there are 4 different phases to a build within CodeBuild. There's an install phase, a pre-build phase, a build phase, and a post-build phase. So, and here in our install phase, we might do things like install testing frameworks. Maybe we're using Ruby and we install RSpec, or JavaScript and we install Mocha. In pre-build, we run commands that we need to run to allow us to access dependencies. So here, for example, in our demo, we're going to use our pre-build phase to log into Amazon ECR to be able to pull our push our Docker container images. In our build phase, we're going to, actually do the work. We're going to run, our build process. Maybe that's running compilation. Maybe that's running some tests. Maybe it's both. And then finally, in our post-build, we're going to take the built artifact and do something with it. Maybe we're going to push that build to Amazon ECR, or maybe we're going to package up the build and prepare it for delivery via Amazon S3 or some other mechanism. And I just want to show you a quick build specification. So it's very straightforward. So there's only a couple of different directives. The only missing one here, there's an environment variables directive where you can specify environment variables. But here you can see we have our phases defined. And this is a working build spec. So here we're logging into an Amazon ECR registry. We are building a Docker container image, and we are pushing that built image in our post-build phase. So a few best practices here on the actual build process side. So minimizing your spend on build resources, we always want to ensure that customers are as cost optimized as possible, and the build tier is a great way to do that. You want to balance cost optimization with agility. You don't want to sacrifice capacity for your development team for cost, but there are ways to extend your buying power by using managed services like AWS CodeBuild, where you get per minute billing, or the EC2 spot instances in the spot market, where you could bid for the amount you're willing to pay for your build instances. And as I mentioned, Jenkins has direct integration with a spot market through a plugin, so it's a great way to very quickly shave some money off your monthly bill. Next, we've seen, with Docker, when you build an image, and what we saw in our last slide, the default tag is going to be this latest tag. We tend to find that, we always recommend to customers to tag artifacts to some sort of source control revision. Maybe that's the first 8 characters of your Git SHA, if you're using Git as a source control system. Maybe it's a semantic version, but something that tags it so that you can directly compare or correlate a build in a Docker container image with code in your source code repository. This is going to make things like rollbacks a lot easier. It's going to make it a lot easier to be able to identify which changes are in which revision. So to that end, an anti-pattern that we typically discourage is using the latest default tag or some kind of production tag or some sort of tag that changes and the underlying image underneath it changes. We typically recommend put some sort of identifier on it that's immutable and save that in your repository. And then optimize for build speed. So make sure your build is as fast as possible. As I mentioned, if you're waiting for a change to go through the pipeline into production, you want to ensure that you're doing the minimum amount of work possible. So things like co-locating your build process with your artifact repository to ensure that save some time on over-the-wire push time. Ensuring that your build is doing the least amount of work possible by doing layer caching, like we talked about before, or extracting a base image. Whatever it takes you want to get the most performance out of your build process. Okay. So now, we've walked through sort of what a Docker container image is and how we might build it using AWS. Let's talk about the deployment stage now. So running a single Docker container in a cloud provider is a pretty straightforward exercise, right? You can script that maybe through using automation like user data. You can have an instance come up and pull an image and run it as a daemon and ensure it continues to run. So that's very straightforward to do. But the reality of how folks use Docker is that it's not just one container image and it's not just one container. It's many, many containers or microservices that make up a whole. And orchestrating this becomes a challenge if you're not using some sort of service or tool to help you through that. So we're going to talk a little bit about the Amazon EC2 container service as a way to solve the problem of orchestrating containers on EC2 instances. The EC2 container service is an orchestration system that allows you to run what we call services, and services are managed groups of tasks on EC2 container instances, and that integrate with things like elastic load balancing to manage where and when your Docker containers run. It has a lot of features out of the box that just kind of work. So things like when you spin up an EC2 instance, one of the best practices with doing that is to set an IAM instance profile and scope down the permissions that instance has to the least amount of privileges it needs. With the EC2 container service, you can give a task individual permissions, just like an instance. You can do auto scaling, so you can scale your service to have more containers or less depending upon your load. Lots of the kinds of features you would think about using on AWS with instances. Amazon EC2 Container Service allows you to use those features within the context of containerized workloads. So the components here are, we have our tasks, which are running on EC2 instances, and we have the Amazon ECS service, which is managing those tasks through an agent that's installed on each EC2 instance. And we have some kind of deployment automation that's talking to the ECS service. So what we're going to talk about now is what that automation is and how that works. And in deploying to ECS, there are lots of different strategies you could employ. But what we're basically going to walk through now is how do we get code from our source code repository onto ECS? What's the actual orchestration of steps that happen? When does my new version go out? How do I integrate testing into that? What are the different patterns? So let's dive right in and talk about the first pattern. So here, we're going to be deploying a service in place, meaning we have a service defined on our ECS cluster, and that service has, here we have 2 tasks running, and there are several different levers we have for controlling how deployment happens. So here we're saying our service can have 2 tasks running, and we want to ensure that we have at least 2 tasks running at any given time. But it's okay to grow up to double the size of the service, meaning we can have up to 4 tasks. That's fine. If during deployment we have 4 tasks running concurrently, that's okay for this service. So these settings permit the service to grow double its desired size during deployment. So here, this is the first stage, and in this stage we have 2 tasks running. They're identical tasks running in separate availability zones for high availability, and we do a deployment. So the first thing that happens when we do a deployment is that ECS starts up 2 new tasks. These 2 new tasks run on our container instances. Now our service is 200% of its size. The next thing it's going to do, once those tasks register with the load balance and our load balancer and are deemed to be healthy, is it's going to stop the existing tasks. So that's a deployment where we're doubling. So we're doubling the size of our cluster. We're using health checks to ensure that our new tasks are healthy, and then ECS will stop the pre-existing tasks and bring us back to our desired count of 2. So that's a pretty standard way to deploy on ECS. I want to go through a variation of that, more of a rolling deploy, where in this scenario we have 2 tasks again, but here we're saying, we don't want ever to grow up to more than 100%, meaning we only want 2 tasks ever across our service. And during deployment, in order to facilitate deployment, you can shrink the service to 1 task, meaning you can go down to 50% of our desired count. So here, the first thing that would happen is ECS would stop one of our tasks, right, to make room within the service for deployment. It would start a new task, and that task would register and ensure the Elastic Load Balancer would do a health check to ensure it's healthy. Next, we would start a new task on the first instance and start a new task on the second instance. So that's sort of a rolling deploy where we're telling ECS in our service configuration we want at least one task to run at any given time, and we want no more than 2 at any given time. So that's sort of a rolling deployment strategy. Next, I want to go through a Canary deployment strategy. So a Canary deploy is taking our new revision and running it on for some number of requests of production traffic. So maybe we want X percentage of requests to hit our new builds, that we could monitor it both on an operational basis and on a check our business metrics and ensure that the new software revision performs as we expect. So here we have a single service with 3 existing tasks running. We are going to run an additional task as our Canary, in a new task definition, and we're going to deploy it in the same application load balancer. So now we have an application load balancer with 2 services running. One is our existing service, and one is our Canary service. And so all 25% of our traffic now is going to go to this Canary service. Once we're satisfied that our Canary service is operating as we expect, we can deploy our new revision across our cluster and stop running our Canary. So that's one strategy. And in our deployment pipeline, we could actually integrate automated testing, maybe acceptance tests, maybe other tests against our new build. And then we could finally kill the Canary. So next, we're going to go through some blue-green strategies. So there are just two more here, just to give you a sense for the different kinds of ways to deploy. So here we're going to do blue-green with a DNS swap, meaning we're going to actually build parallel infrastructure, meaning a new ECS service and a new application load balancer. So our first step, we have www.myproduct.com pointing to 2 tasks. We're going to spin up parallel infrastructure. So now we have a new host, let's say next.myproduct.com, pointing to our new software revision. And we could now test next.myproduct.com, maybe with an automated testing through our deployment pipeline. Maybe there's some manual testing going on. Maybe it's a combination. But once we're happy that our new software revision is performing as we expect, we can swap the DNS name. So now www.myproduct.com is pointing to our new revision. And we can, once we're happy with that, we can remove our old revision. So that's with a DNS swap. Now that target groups, we can also do a target group swap. Now that target groups are in the application load balancer supports routing, host header routing, we can leverage that to do a target group swap to allow us to deploy with one elastic load balancer across 2 different services. So here in this scenario, we have 2 tasks running with www.myproduct.com, and we want to deploy our new revision. So we're going to deploy that as a new service with a new host name, next.myproduct.com. It's all routing through the same application load balancer and with different target groups. We can, again, do some testing, either automated testing or manual testing or some combination. And when we're happy with how things are going, we can kill the old service and move the target group to point to the new software revision. Okay. So just some best practices here on the deployment front. So using elastic load balancing health checks, if you're running a web application or a service that's speaking HTTP, using health checks will help you prevent bad deploys. So if you have a health check that's defined that hits the service and expects some sort of results from that service, and that service, the endpoint you're hitting drives all the way through the stack, you'll be able to prevent problems early and ensure that if it misses your testing, that it won't actually deploy those new tasks. And for higher confidence, integrate automated testing against the new environment, or with canaries you could monitor before a cutover. And then lastly, and this is one that's sort of subtle, with all of these schemas, all of these different strategies, we're through some amount of time, we're operating multiple revisions of our application in production. So we want to ensure that our application can function against the same, like maybe backend database or backend dependencies for adjacent releases. In the rolling deploy or the doubling deploy, we have 4 tasks up in the doubling running different revisions. We have to ensure that all 4 tasks can operate concurrently. Okay. So let's go through and put all this together. So now we talked about deployment strategies. We talked about building Docker container images. Let's look at a deployment pipeline here. So just as a definition, so a deployment pipeline is the automated manifestation of the process for getting your software from version control and into the hands of your customers, right? You have some process for doing this. Maybe it is communicated to your team through tribal knowledge, or maybe it's verbally known. Maybe you have an Excel spreadsheet or some sort of wiki page with a checklist. Taking that and automating that process and all parts of that process, from getting the new revision from source control, building it, testing it, and deploying it. And the same stages apply. We have a source stage, build stage where our artifact is created, a test stage where we test our new component, and the production stage where we not only deploy the code, but actually monitor it. And CodePipeline is a service that lets you model deployment pipelines and run them and manage them, which build, test, and deploy new revisions of code changes. So CodePipeline integrates with AWS services as well as open source and third-party tools. Things like GitHub and AWS CodeCommit are supported as source steps, for example. For building and testing, the two systems I mentioned, AWS CodeBuild and Jenkins, are supported. And it allows you to model your deployment pipeline and also operate it. So it allows you to do things like block transitions. You can have manual approval steps to integrate that into your pipeline if that's part of your process, etc. And so here's an example pipeline. So here we have a pipeline of 3 stages: a source stage, a build stage, and a deploy stage. We have within each stage actions, 1 or more actions. So here we have 1 action in each stage. And after that stage runs, and after those actions in the stage run, we have a transition to the next stage. So here we're getting code from our GitHub source code repository. We are building our code using AWS CodeBuild, and then we're using AWS CloudFormation to run a deployment of our new, change our environment to deploy our new revision. And what this looks like, in terms of the different components is something like this. So we have, developers pushing code to a source code repository, where we have some sort of component that's orchestrating the testing and building and deployment. We have 2 different tracks here. So, we're building our code, our image from the source code, and then we're pushing that to a container image. And then up top, we have some automation that's changing our infrastructure to use the new image. And we have a container orchestration system like Amazon ECS that's taking that new code and that new image and running it. So what this might look like, so here's the demo we're going to walk through. So here we've just filled out the categories of component with AWS services. So we're storing our code in AWS CodeCommit. We're using CodePipeline to orchestrate the work. So it's polling our source code repository and monitoring for changes. When a new change occurs, it's going to use our AWS CodeBuild to build our artifact and push that to Amazon ECR. We're then going to use AWS CloudFormation to manage our Amazon ECS service. So we're going to use CloudFormation to update Amazon ECS with the new image. And Amazon ECS will then pull the new image from our EC2 container registry from Amazon ECR and update the service and use that new task definition to run the new service. And likewise, as we mentioned, there could be other tools in here as well, right? Maybe your pipeline actually has GitHub as a source code repository. Maybe you have Jenkins that's actually doing the orchestration. Perhaps you're using Jenkins to not only build your Docker images, but also to change settings within your container orchestration system. Yeah, and perhaps that's driving CloudFormation in Amazon ECS. So there's lots of flexibility. These are tools that work together really well, that are decoupled with really good interfaces for putting together deployment pipelines. Okay, so I want to show you what this sort of looks like. I have a little sample project that I want to walk through, and then we're going to go through the interface of CodePipeline and just put together a quick pipeline. So I'm going to switch into demo mode here. Okay, sorry, stand by. Okay, one moment, share my screen. Okay. So here's the intro page for AWS CodePipeline. This is what we're going to use to build our deployment pipeline. I have a small project here that I just kind of put together just to show the different components. This is a little toy project. So we have here a little Node.js application. You can call it an application. It's a little script that basically just will output hello world to anyone who requests it. So super simple. It creates a new HTTP server. It'll say hello world in a H1 tag, and it listens on a port that's defined in the environment. So this is the small application we're building. With our application, we have a Docker file here that is defining the Docker container image that we want to build with our application. So here we're deriving from the node image, the 7.9 Alpine. We're defining our port environment variable to 80 and telling Docker that we're going to run something on port 80. and we're copying our application in, and we're telling, in our container image, we're denoting that the default command to start is running node and running our application. Okay, so those are the two components of our code base. Super simple, easy to understand. We have components also in our repository here around building the Docker image and also deploying it. So we have a build spec. So this is our build spec for our Docker container image. Here we have a few commands to, on the pre-build side, where the first command will log into our ECR Docker container registry on ECR. And then we're going to grab a tag. So we're going to use the resolved source version. This is the git SHA, essentially. And we're going to grab the first 8 characters of that. So that's going to be our tag. So in our build command on line 9, we are building our Docker container image. We have a repository, which is set in our environment. And we're going to use the tag that we've created on line 6 to build our image. And finally, in line 12, we're going to push that image into our Docker container registry. And we're going to write a little JSON file here. This is basically an output file that will tell our deploy step where our image is. So here we're saying our image is our repository : our tag. And then here we've defined our output files. So build.json is the file that this line creates. And then we have 2 CloudFormation files. So the first file is a template that defines our service. And the second file is just a configuration file that I put together to define our environment for this service. So we'll just quickly take a look at that. So here we have a simple YAML file with some parameters. We have cluster, how many tasks we were running with on our service, what's the image, that's the bit that changes on every deploy, our IAM role for the service, and our target group. So what's our load balancer for the service. And in our JSON file here, we have some default parameters. So here we have our cluster is called cluster. We're running 2 tasks. We're using an ECS service role. We have our target group defined there. And then here, we're using that JSON file we created in our build spec and extracting the image attribute from that file to update our service. So image will be dynamically, that's on line 32 here, this will dynamically change depending upon the output from the code build step. So that's our simple project. We're just going to run through very quickly and configure that within CodePipeline, excuse me. So here we're just going to have a little pipeline live demo. And our source step, we're going to say AWS code commit. That happens to be where I have this code, our CodePipeline demo, and our master branch. So this will pull our CodePipeline demo step. Excuse me, and it will start the pipeline on any time new code is detected. Next, we have our build provider. So here you can see there's a Jenkins, AWS CodeBuild, and Solano CI, which is a third-party CI system. So we're going to use CodeBuild, and we're going to call our project live demo. Oh, we're going to create a new project, excuse me, live demo. And we're going to say our runtime is going to be Docker, because we're building a Docker container. And this is a version of the CodeBuild environment. We're going to tell it to use the build spec that we just looked at in our source code repository. And we're going to set an existing role that I created just prior. There we go. And then we're also going to set, we had that repository setting, excuse me. We're going to just set that as well. So here's our Docker container registry. And here's our registry URI. So we're going to set that because that's static. It doesn't change from build to build. Okay, so we're going to save that now. Cool. Now we can move on to our deploy step. So here we're going to deploy using AWS CloudFormation. And we're going to create and update a stack. We'll call our stack live demo. Our template file is the that service.yaml file we looked at. And our configuration file is that production.json file we looked at. Give it a named role, and we'll call the role CloudFormation role. And okay. And then we have a role for CodePipeline, which gives it the ability to interact with all these different services. Okay. So now we have a pipeline. We click create, and there's our pipeline all created here. So the first thing it's going to do is pull the source code repository, find a new revision, and run it through the pipeline. So this will take several minutes to complete, and we're already close on time. So we do have, I did put together a quick version right before this webinar that shows what this actually looks like. So our source code repository runs. It links to code commit, which shows our links right to the commit that authored that triggered the deployment. So here's our code. And the next step is CodeBuild, where it builds our Docker container image. So here's CodeBuild. Here are all the steps that it went through: pre-build, build, post-build. And here's our log of what actions it took. We could also we can look at a full log within CloudWatch logs if we wanted to do that to debug something. And then finally, CloudFormation. So here's our CloudFormation change, our update, that updated the service within our stack. So this allowed us to take an image that was previously there and swap it out with our new revision. And then, our exciting little hello world works fine. So if we were to push a new revision of our code and change that to goodbye world, it would run through, build the image, push it to Amazon ECR, and use CloudFormation to update the image to our new revision and deploy that change. Okay, so that was just a very quick demo. We do have, if we go back to the slides, click stop sharing, sorry, one moment. We do have a reference architecture on GitHub, on AWS Labs, that you can really spin this whole thing up in your account and kind of see how it works with your own projects. It has templates that build a sample ECS cluster and a deployment pipeline. So you can get this spun up within a few minutes within your own account and kind of see how the mechanics work. Okay, thank you so much. We have a